Okay, Algebra 2, I am on page 625. I'm looking at example 2. The instructions say write an equation given the asymptotes. Okay, so reminder, an asymptote is that dotted line or the dashed line that the graph does not cross or touch. Okay, so this time they're giving us, look in the instructions, they give us two lines in slope-intercept form. They said y equals 5/3 x and y equals negative 5/3 x. These are the equations of the asymptotes. Okay, so this is the slope equation. It should look like y equals mx plus b to you. Y equals, this is the m, this is the slope of the line, x, and then plus b just means that the line's going through 0. So I can tell that the asymptotes are crossing at 0, 0 because there is no y-intercept on these equations, which means that that's going to be the center of this hyperbola. All right. Now, another way to find the center, and that's what really matters. Okay, another way to find the center is look at the 2 points of the vertices they gave us. Reminder that the vertices are equal distant from the center. So what we could do is we could use the midpoint formula to find the halfway point. And remember, midpoint formula is x plus x divided by 2 and y plus y divided by 2. So if you just hang with me, 0 plus 0 is 0, right? 0 over 2. And then 5 minus 5 is also 0. So 0 over 2 and 0 over 2 reduced to 0, 0. So our h and k here is 0, 0. Okay, so a couple of ways to tell. Remember, you can look at the y-intercepts of the asymptotes, and you can also do the midpoint formula between the vertices. All right, so we know that the h and k are going to be 0, and when we plug them into either formula here, okay, and we plug them into either formula, it's just going to be like an x squared and a y squared on top, right, or a y squared and an x squared, depending on if it's horizontal or vertical. Now, if you can't tell already if this is horizontal or vertical, my suggestion is just to kind of like plot these points on a coordinate plane. If I just drew a plane here, where is 0, 5? Well, 0 is here, right? We don't go left to right. We go up 1, 2, 3, 4, and there's my 5, right? That's a vertice. And then we have a 0, negative 5, which is going to be 1, 2, 3, 4, and 5. All right, so these are the vertices, and it looks like the hyperbola, right? The foci would be inside somewhere, inside the bell, but those 2 points were the vertices. So this looks like it's a vertical hyperbola. We're going to use this formula right here. Okay, so my suggestion is just take the vertices, just do a quick graph to see which way it looks like, and then I'll tell you which formula we're going to use. Okay, so this problem is actually relatively simple. Now that we know that h and k are 0, 0, okay, all we need to figure out is a and b, right? A and b. Well, the good news is the asymptotes, okay, at least for and this is at least for a hyperbola that is centered at 0, 0. If you look at the key concept box on 624, it'll show you the equations of the asymptotes at the very bottom, okay, which are these formulas. Plus or minus b over a x, that's the equation of the line. This is also in slope-intercept. Look, y equals mx, and then there's no b back there because it's centered at 0, 0, like we talked about up here. All right, so if you go over one more page before we start, I know I'm talking a lot today. If you go over to the key concept box on 626, you'll see that the equation of asymptote, the lines are a little different when it's not centered at 0, 0. But since this one is, we're just going to use these two formulas right here. So, super easy. This is the horizontal one. We don't want that. We want the vertical one, which is plus or minus a over b. So let's look up here. See how it's plus and minus? One's positive, one's negative. A is the top number, so 5 is A. And B is the bottom number, so 3 is B. Okay? It's pretty simple. Once we have those, we square them and put them into our formula here and here. Yep, it's that simple, guys. It's not too big of a thinker today. So I'm going to go ahead and say y squared. Remember that k and h are 0, so y minus 0 is just y. So I have y squared over a squared is 5, so I'm going to say 25. I'm going to say minus. Remember, hyperbolas are minus. The ellipse is plus. X squared over 9, and it's always equal to 1. Okay, so that one is the equation for example 2, right? That's the equation for example 2. Okay, let's go over to page 628. We're going to do a very similar problem, but in this case, look at number 3 on 628. Look at problem 3. Do you see the two asymptotes? It's actually drawn this time. They gave us a graph, which last time they didn't. They just told us what the equations of the asymptotes were. This time, we're going to have to find them. So, this one's not that tricky, even though it looks different. If you look closely, you can see that the asymptotes are crossing at 0, 0 again, which means the center is at 0, 0. So we're still going to use these formulas here. Also, if you look at the vertices, negative 8, 0, and 8, 0, if you did the midpoint between those two, guess what? It would be 0, 0, proving that the center is again at the origin. All right, so what we're looking for is we're going to have a line that's going to look, it's going to look like this. We're going to have plus or minus a number over a number timesing x, right? And one will be positive and one will be negative. All right, so let's figure out how to find the slope of a line. You guys know this from Algebra 1. Count, right? They gave us the line. Let's just count. So I'm going to bring my book into view here, okay? So we can find the equation of this asymptote. Let me get my pen here. So I'm going to use the camera by hand, you guys. It might get a little shady for us. Okay, I'm going to try. Okay, there we go. All right, so here's number 3, and just a reminder that these are, it looks like they're being marked by 2, right? So every spot is 2. So remember, to find the slope, all we do is count. Let's start at 0, 0 here. We're going to count up and over to 8.5 or 8.5. Do you guys see that? All right, so we go up 2, 4. Looks like we're going up 5, right? So we go up 5 and over 2, 4, 6, 8. So it looks like it's up 5 over 8. You guys know that that slope then is 5/8, right? It's 5/8. Okay, you could do the same thing for this one. We could go down 2, down 4, down 5, over 2, over 4, over 6, over 8. So this one would be negative 5/8, which is the plus minus. All right, so I'm going to come back. Hang on a second. Yeah. I'm going to come back to my chart. We just said that we found the slope of problem 3. Right? The slope of problem 3, let me get a marker here, okay, was the slope we had of the asymptotes was 5 over 8x, and the other one was y equals negative 5 over 8x, right? Those were our two options. So those are the equations of the asymptotes. Let's use those with, I kind of crossed them out. These formulas down here, remember that this one is horizontal and this one is vertical. So let's look at the graph. Is this a horizontal or vertical hyperbola? It looks horizontal to me. So we will use this first one, the one I crossed out. Remember, the number on top is b, so it looks like b is 5. And the number on bottom is a, which is 8. And remember, we already said that h and k, guys, we're using this one, right? We're using this one because it's horizontal now. H and k were 0, right? We did the midpoint between the vertices and came up with 0. So let's just square a and b, and we're going to plug it in up here. All right, so I'm going to write it down here. I'm going to say x squared. Remember, h was 0, so x minus 0 is x squared. Over a squared is, was that 64? Minus y squared. Sorry, I got lost in my thought about if we had the right a's and b's. It appears that b is correct. Over 25 equals 1. So this looks like the equation of number 3 there. Okay, that's the equation of that line for number 3. Okay, guys, if you have any questions, let me know. Otherwise, good luck to you. I want you to try a couple of problems here. I'm going to flip this sheet over. Let's see. I want you to go to page... I lied. I want you to try one problem for me. Go to page 628, and let's do number 13, please. All right, 628, number 13. Good luck.